what's coming up. So you should expect 2 more quizzes, okay? One will be about, you know, trig functions and inverse and so on and so forth. And the next one is a review quiz on exponential and logarithm. They're still in the making, so I'm not quite done yet, okay? So yesterday we covered the inverse function of the constrained method sign, right? We talk about these, you know, interesting features, which is consistent with functions that are inverse to each other. And we made the tables, okay? So did you guys have any questions about the tables? Right, so we have completely filled them, right? And you clearly see the one-to-one feature, right? And we talk about the no-fly zones. And today, we're going to continue on these topics and to look at, there's another interesting properties about inverse functions that we're going to run by. And we reviewed for any pair of functions that are inverse to each other, one's domain is the other's range. And in the case we have studied before, like the exponential functions and their respective inverse, and we have that relationship. Now, for this new pair we're talking about, right? What is this new pair? Okay, so I'm going to bring the table of summary, which I did for the other class over here. Okay, I'm going to bring that table of summary. So I'm going to go adjust a little bit. No, not faster, you know, we're fine. So let me bring that table over here. Okay, so hopefully that will save some time. Okay, I'll give you time to write it down. Fall. Today's lecture, the 7th. Okay, I made a table summary for the function we have open. Okay, so we have that table of summary right here, right? Right here. Okay, so yesterday we talked about, or in the last 2 days, we talked about that sign, this sign does not have inverse, its domain is all real numbers, right? And we created a new function. We put some constraints about that function. And then this function is also have the same name, but different domain. And these two functions are inverse to each other. So I've been working with that. And we put these two pictures together, right? Did I put these two pictures together for you? I might have not. I think I haven't. Did I put that two pictures together for you? No, not yet. I think I didn't. Okay, but it's here. It's there. Okay, so let me make the fonts a little smaller so I can bring that picture to you. And I brought it here, right here. Okay, so this picture, right? So this picture, when these two are in the same frame, right? When they're in the same frame, what do we see, right? The red is the arc sign. The red is arc sign. The green is the G. The red is a G inverse. And there are points, they're symmetrical with respect to this line, y equals to x, just like all the other inverse functions we saw, okay? Exponential, logarithm, and so on and so forth. And the points we plotted, right? They're in the table. So you guys have, you know, the next quiz is going to be about how do you identify those points, right? Identify those points. Which one is input, which one is output, right? And next, what we want you to understand is that G, just like sine, right? Just like sine, the input are angles. These are angles. The inputs are angles, okay? In radian or in degree, doesn't matter, okay? It could be in radian, it could be in degree. We talk about them, they're just angles, right? They're just angles. It doesn't matter what symbol you use, okay? So the input are angles, the output are ratio. And G, same thing. How about the inverse? The inverse has input is ratio, the output is angle. And to summarize what we did yesterday, right? It's about their domain. It's about their domain. Wait, okay. I'm sorry, this is like a little bit messy, okay? Their domain, right? We know the domain for the sign we know of, we're very familiar with, and this is the sign you always know of as the domain is from negative infinity to positive infinity. This constraint, this function G actually rarely show up, okay? So anytime sign is mentioned, we always mention this sign. Okay, we always refer to this sign. This guy is rarely used, rarely mentioned. Where do we see it mentioned? Okay, I will show you where do we see it mentioned. Okay, and the G inverse. So the F and G inverse, they're not inverse to each other. They're not inverse to each other. They're just not that pair. So who are the pair? These two are the pair. These two are the pair. And sometimes, in most of the cases, this other guy is not available. It's not explicitly mentioned. It's not explicitly mentioned. So in the future, when you say, oh, in the question, the professor mentioned the sign. Which sign is it? It's always the first one. It's always the first one unless it's otherwise specified. Because if they specify differently, they will tell you explicitly. If it's not told explicitly, it's always referring to this guy. Do you guys follow me? And we will see this in the following lectures. All right. So with that said and done, okay. So we take these two functions. We know they're inverse to each other. So I'm going to take these two functions, okay, and we're going to look at these properties. And what property did we left off, right? We left off this property yesterday. We want to see what would this lead us to. Okay, we want to see what would that lead us to. So this pair. Okay, so let me make the fonts just a little bit larger. So that's a recap from yesterday. Do you guys have any questions? So 175%. So you get to see the -1 here. Okay. We see that for any pair of functions that are inverse to each other, right? So this is true for any pair of one-to-one function. Okay, one-to-one function. And its inverse, which is f of inverse. And the following is true. And of course, there's no exception in our case, right? In our case, it's still true. But in our case, in the case of G, a G inverse, which is, G and the G inverse, of course, is still true, right? It's still true. And G has its domain and has its own range, right? We'll be building the stages and do the ARDs and do the truncations, and we have done a lot of things in this week and the last week, right? And they all are now coming together. So in the case of G, it is still true. We just have to change F to G. So this is going to be changed to G inverse, and that's going to be G. And what will be the X from? X will be from the domain of G. And this will be G, and this will be the G. G, right? And that will be from the inverse of G. So are we good? You can see in the special case, this is the general statement, always true. In the special case, it is also true. But if we apply what actually G is, okay, what is G? So now if we apply what a G is sine of X. So X will be in the domain of G. What is the domain of G? Right here. Domain of G. What's the domain of G? Right here. That's the interval. And what's G inverse? ArcSine. You follow me? You can see that in special case, these will turn into the special case. G. What is G? G is sine. What's G inverse? ArcSine. And what X belongs to? X belongs to the domain of G inverse. What's the domain of G inverse? What's the domain of G inverse? Right here. From -1 to +1. Okay, so the domain of G inverse is from -1 to +1. So in our special case, we will get these two statements. And where do we see these two statements in the table, in the notes? Trig 7a. Trig 7a. Okay, could you guys find trig 7a in your notes? On trig 7a, there are two tables. The table on the top are the properties, okay, the truth. The table in the bottom, which is a larger table, longer table, and those are the exercise, homework. Okay, so you're going to start doing homework in this section. All right, so that's the two properties on the top of the first table. Okay, so what I'm going to do is that I'm going to, for transportation, right? So I'm going to put them in this way, in that way, right? For our convenience. All right. Now, the big picture, right? The table I just copied, the table is 3. Okay. Let me copy this whole thing. So we're going to address these issues one more time. The big picture. We have 3 functions involved. These two are inverse to each other. And this guy has no inverse, And these two are inverse to each other. And the one in the middle, I said that this one in the middle is rarely used, R-A-R-E-L-Y, okay, rarely used. When it shows its face, when does the middle one show its face? It shows its face here. Okay, it shows its face right there. So when this is true, only when X is between -pi/2 to pi/2. So you can view that the G sine of X is a part of the F. Okay, because it's just a small piece of it. We know that from the way we construct it. But when you see sine, you actually always see this guy, unless otherwise specified. So this is the unless otherwise specified. Do you follow me? That's unless specified. So to make you understand this better, so let's look at some exercises. Let's look at some exercises, okay? So we're gonna get started. We're gonna get started. Okay, you ready? So we got these two properties and we got the big pictures, right? So let's look at trick 7a. Trick 7a. Okay, the first one and the second one. Okay, the first one we got a question, say sine, and obviously we're not given a special angle. Okay, we're not given a special angle because you can tell we have a 3/5. And we want to find out what that equals to. We want to find out what that equals to. So now there are two functions. So this is a composite function. Composite function is not new to us, right? So here you can see what there's an input. The input is 3/5. Okay. The function immediately applied to 3/5 is ArcSine. So 3/5 is a ratio. So this ratio is the input for ArcSine. Okay, for ArcSine. ArcSine. Okay. So we know that ArcSine has a domain from -1 to +1. So this piece must be from the domain. Must be from the domain. What will be the domain? -1 to +1. Right? That condition has to be satisfied, which it is. Okay. And then the output is actually ArcSine of 3/5. When you look at this quantity, we need to understand this quantity is going to be where? This quantity is going to be where? This quantity is going to be inside. Where is it going to be inside? Inside the range of ArcSine. The input is in domain, therefore the output is going to be in the range. And what is that range? And that's the range. The range is between -π/2 to π/2. That's the range this guy would be in. You guys follow me? So we got the output. So when you see ArcSine 3/5, you actually see an angle. This is an angle. This angle is going to be where? Between -π/2 to π/2. Okay. It also means, it also implies, right? On the unit circle, remember we talked about the no man's land, right? And this is the function that's we are talking about. ArcSine. The domain is from -1 to +1. The -1, you see the blue number, okay? The range is between -π/2 to π/2, which means that you can only measure the angle as counterclockwise all the way up here. That's the limit. You cannot go further. You cannot go around and round. In clockwise, you can only measure up to this point, no further, no round and round. This is what we talk about, the no flight zone, right? Quadrant 3, quadrant 2, you cannot fly over, okay? You cannot get into, you never get into it. You follow me? That's the implication. That's the implication. Don't get there. Don't get there. And now this angle, which we don't know, but we know because we know it's arcsine 3/5, right? So when we draw the terminal, even though this is not a special angle, and there's a point on the unit circle. There's a point on the unit circle. So let me draw that point on the unit circle. Okay, so this point on the unit circle. Wow, that green color is not that visible, right? So this point, okay, this point on the unit circle. And this point also has a blue number and red number. A blue number and red number. The blue number will be for the sine, the red number is for cosine. Okay, so what would be the blue number? What would be the red number? So there's a red number and there's a blue number. Okay, just like those specials, right? So what will be the blue number here? The blue number actually is given to us. And what is it? The blue number is 3/5. Do we know the red number? No, we don't. You can find it. I know you find it. You know, one of the quizzes actually is to find it, right? Quiz number 10. The red number here is going to be what? We don't need it, right? But if you want to find it, you can use Pythagorean theorem to find it. Do you follow me? Okay, it's 4/5. But here we don't need it. Therefore, we're not going to go out our way to find it. Do you follow me? Do you follow me? Okay, so this is from ratio to find angle. From ratio to find angle, what would that be? How do we classify that kind of question? From ratio to find angle. Ratio are the definitions, right? Ratio are the definitions. If you look at it from ARD's perspective, if you look at it from the perspective of ARD, right? So we know the sine ratio is what? Is sine, right? So we know definition and we're looking for what? We're looking for angles. Okay, and what is that angle? That angle has to be between -π/2 to π/2. And what is it? Then you say, hey, tell me what it is. You know what? You have to enter the number in a calculator, but you don't need to. Because you can regard this arcsine 3/5 as an angle, and that angle is the highlighted arcsine 3/5. And what comes next is that this output from the previous function will be served as input. And that input will be given to for the sine function to apply. So the sine function will apply to this angle. Sine of this angle equals what? Equals the blue number. What's the blue number? The blue number is 3/5. You guys follow me? And of course, you rarely see this kind of expression in the textbook, right? They don't do that. Okay, I do that because I want you guys to see the composition. Okay, I want you guys to see the composition. Okay. All right. There are other ways to do it. There are other ways to do it, but let's just look at the property we just got. Let's just look at the property we just got. The property we just got, it says sine of arcsine 3/5 equals to what, right? If you look at the first property here, look at the first property here. The sine matches the sine. Arcsine matches the arcsine, right? Knowing the mechanism, right? Knowing how it works. And if we apply the property, this property here, it says if x is between -1 to 1, 3/5 is between -1 to 1. Therefore, this properties already tell us it's a 3/5. And so applying this property when it applies is more or less like a shortcuts. So these are shortcuts. But we know that shortcut doesn't always work, right? So these are the shortcuts. These shortcuts sometimes work, sometimes it doesn't, right? What happens if it doesn't work? Well, we are going to look at the situation when it doesn't work. Okay, so without further ado, do you guys understand how we go about? So the first question, actually, the answer is very easy. You just apply that property. How do we apply that property? All you have to check is this x in the specified domain, in the specified interval. And it is, and then the property apply. What if it is not? Then it doesn't apply, right? For example, I'm going to give you another example here. Any questions so far? Number 9, for example. What does number 9 say? Number 9 says sine of arcsine 3/4. What would that be equal to? If you look at that property we just have there, if we look at, whoops, I'm sorry. Sorry. Lost myself. There, right? Sorry about that. I merely just want to copy and paste that fabulous shortcut. Okay, so for this shortcut, I'm just copy next to it. Does that property applies? Does this property applies to our number 9? No, why? Because 3/2 is outside the specified interval, right? You don't say the range is different. There's no range specified. The range is, what range you're talking about? You're talking about the range for arcsine? We're talking about the range for sine. It's not about range. It's about the input outside the range, outside the specified interval, not range. The input is outside that interval, okay? So when we use the words, we need to be very, very careful, okay? Range means the range in the mathematical context, okay? So this, you would say it's undefined. Undefined, then what would you say? Because 3/2 is outside the domain of arcsine. That's what you say. Okay, you don't pick up random words and just put it there. You have to use the vocabulary. You have to use the mathematical vocabulary. Otherwise, you professor don't understand what you're saying. Or we have to clarify. Do you guys get it? Right? Well, thanks for trying. Thanks for trying. So in this case, it's undefined because the input is outside the domain of arcsine. And that's it. That's the reason. Other reasons is beside the point. Besides the point. Any questions so far? Next, I want to show you another way to, actually we already covered, right? We covered the input, output, right? We did. I think the other way I like to use this example is using ARD. Okay, it's using ARD, right? Sometimes we do ARD, sometimes we do DRA. We just use DRA because we know the ratio, we know the sign ratio when we do from inside, right? And then when we do the outside, we do ARD. So it's inside is DRA, outside is ARD. Okay, the outside is ARD. So do you guys want to try number 2? Do you guys want to try number 2? Okay, let's try number 2, your turn. Okay, in the notes, number 2. What do we have for number 2? Everybody should have open the file of the notes. Will you? This is not a special angle. This is not a special angle. I'm going to give you a couple of questions. Okay. The trig 7a, we have, we have sine, cosine, tangent, cotangent, and arcsine, arccosine, arctangent, arccotangent. We haven't reviewed all of them, but today's homework, you'll be only doing for sine, arcsine related, okay? And the rest are optional, okay? Some of you may be ready for it, some of you may not. Okay, but we're going to continue to cover that on Monday. We're going to cover arccosine on Monday. I will cover arcsine, arccosine, arctangent for you as thoroughly as possible. Okay, arccotangent, I may not spend as much time. Okay, but you need to understand that these functions are, to understand these functions are very, very useful. Understand these rules. Okay, so I'm giving you number 2. Number 5 and number 6. Okay, so we get to apply our composition. In my other class, people asking me about what's ARD. Do you guys still know what's ARD? So from time to time, I need to check on you. Do you guys still know what's ARD? If you don't know it, you certainly would not know how to use it, right? ARD are the 3 pillars of trigonometry. Every question you do, they're either ARD or, as I promised you, or DRA in reversed order. So you're either given A to find D. D means definition, right? The 6 definition, sine, cosine, tangent, cotangent, secant, cosecant. Or you're given the definition and you're looking for A. You're looking for the angle. And what's R? R is the bridge. R is the bridge. Okay. So now, are you guys ready? Are you ready for number 2? What's the answer for number 2?
-3/4.
That's right. You just apply the property. The property applies directly to it, right? -3/4 is in the interval. Therefore, the answer is just -3/4, right? How about number 5? Number 6. Sorry?
Oh, I was going to say for number 5, isn't it pi over 3?
Because the second property applies, right?
Yeah.
Very good. So you can see these are the shortcuts. These are the shortcuts. Then you say, well, what if I forget? What if I forget? If you forget, it's not a big deal. Okay. For example, if you forget for number 5, right? So we're done with number 2, 3, 2, 5, 2, 5, 6. We're done, right? Then you say, oh, you told us you don't want us to have to memorize things. Yes, I agree. I don't want you guys to have to memorize a lot of things. I do. Okay. That's why we spend all this time to explain, to understand, right? So suppose you forgot. Suppose you forgot, okay? In the case of number 2, okay, I'm going to show you the alternative. If you forgot, no problem. No problem, okay? You know that from arcsine negative 3/4, you basically, you know the sign ratio. You know the sign ratio, right? We know the sign ratio is negative 3/4, right? So we know the definition. So we know, so this is basically, it's going to be a question to DRA because, right? The inside is from DRA, right? So it's DRA first. DRA first. How is DRA? You know the sign ratio is negative 3/4, right? What does that mean? You know that this ratio is negative, so your angle is, the corresponding angle is going to be measured clockwise because the negative ratio is a blue number ratio, and negative 3/4 is probably something, it terminates right here. And once again, there's a blue number. There's a blue number on this point, right? There's another blue number. What is that blue number? What is that blue number? That
Isn't the blue number negative 3/4?
That's right. Negative 3/4. Negative 3/4. I don't need a red number. If I need the red number, I can find it. Okay, we don't care. So this is a red number. There's a red number. Right? That's what it means. Right? The negative, sorry, this is what is the DRA, because you know the D, you know it's a negative 3/4 is a blue number, and that blue number corresponds to a terminal. And that terminal, how is that terminal measured? That terminal measure, because it's arcsine, is measured clockwise. And also, you understand there's no fly zone, no flight zone, right? So you cannot go around and around. There's only one angle. What is exactly that angle? We never know the exact value. We know the exact value actually is arcsine, is arcsine of negative 3/4, but doesn't matter because we're going to apply sine immediately to the angle. Okay, we're going to apply the sine immediately to the angle. If we apply sine immediately to the angle, which is ARD, right? Which is ARD, right? Which is ARD, what do we get? We get the blue number. That's how you get the negative 3/4. Do you guys follow me? Do you guys follow me? Yes or no? Am I too slow?
I'm following.
Okay, good.
No, that's a good piece.
Yeah, you can see if you're just so good at ARD, you will be invincible. You will be invincible. Of course, you also need to be aware of the domain and range, right? For arcsine domain is domain between -1 to +1 inclusive, and under the range is between -π/2 to π/2. Do you need to memorize it? No. If you went through the process I went through with you in the lectures, you carefully watch the lectures, couple times and did the work, you never have to memorize much. No, not much. You don't have to memorize it. Okay, so that's the other way. So if I forget, right, of course you cannot forget everything, right? You still have to know ARD. But if you don't remember this shortcut, no big deal. You can figure out right on the spot because you have the tool, which is ARD. Okay, so with that said and done, what if I forget, you know, for the other two? Same thing, same thing. If you forget, no big deal. You can do it layer by layer. You can do this layer by layer, right? You can still do ARD, right? You first do the ArcSine. You do the inside first, right? Sine pi over 3 is root 3 over 2. Root 3 over 2. You do the ARD, right? So that's ARD, right? That's ARD. Do you follow me? That's ARD. That's ARD, right? You have angle, you do the inside first, and then you do reference angle, you just draw the angles, right? So that's ARD. That's your terminal, pi over 3. That's A, right? So that's A. And the reference angle happen to be the same. And D, you find the blue number. The blue number is root 3 over 2. So that's ARD. So from this step to the next step is ARD. And how about the next step? The next step? What's the next step? Is the inverse function, right? It's the ArcSine. ArcSine basically tells you what? You know the definition is sine. You know the ratio. The ratio is given to you, 3 over 2, root 3 over 2. So you know the ratio, from ratio to angle. From ratio to angle under ArcSine, from ratio to angle, what do? From ratio to angle, you can just look for root 3 over 2, root 3 over 2, root 3 over 2. Right? And there are two terminals. Which one do you pick? Do you pick both? If you pick both, you're gonna get 0.
No, because you have a no-fly zone.
That's right. That's a no-fly zone. I love it. You got it. You can't pick this one because that terminal is outside. It's outside. It's in the no-fly zone. Right? So you have no choice but getting what? Getting what? Getting pi over 3. Do you know what I mean? Do you see the importance of understand the domain and range and how they applies to our particular issues, right? So we're gonna pass, we're gonna pass number 6, right? The same idea. So next, our question is getting a little bit harder. Okay, our questions are getting harder, right? So we also recognize that we either has ARD or DRA, right? So next, we're gonna look at some other questions, right? This time, we're gonna look at number 15 and number 17. Are you guys ready? I'm going to do this pair, but I want you guys to be involved. And then we're going to select 2 other questions and we're going to work it in the breakout rooms, okay, where you work on it individually. And and then we meet up, okay? So we have ArcSine. That's number 15, right? Of sine 3 pi over 4. And this number 17 is negative 3 pi over 4. Okay. How do we go about it? Can we still apply those shortcuts? These shortcuts, if you happen to remember them, if you happen to know them well. If you know them well, you certainly may think about applying them, right? Because if you can apply the shortcut, that's great. You get it done very quickly. Can we apply any one of these two shortcuts? The one may possibly apply is the second one, right? Does it apply? Does it apply? Does this amazing property apply to both situations? Yes? Does it apply? Some say yes, some say no. For number 15, is 3 pi over 4 inside a negative pi over 2 to pi over 2? No, they don't, right? Does a negative 3 pi over 4 inside this interval? Of course not. So they don't apply, okay? Does not apply. So we cannot use a shortcut. What can we do? Any comments? Can we say that sine 3 pi over 4 is undefined? Because this is the moment a lot of our students will be asking, do you mean this is the sine with, you know, the restricted domain or the one-to-one version of sine, or you mean the sine with all real numbers as a domain? This is to respond to what I just mentioned earlier. When you see this sign, anywhere you saw it, it always, always, always refer to the sign that we have studied with domain as all real numbers. So this sign is not referred to those other signs. That's what I meant. This guy is rarely used. This guy is rarely used. This guy is rarely used. I don't mean to cross them. Rarely used. What does it mean rarely used? We seldom use it. We always refer to which one? The sign with all real numbers and domain ranges between -1 and +1, okay? Always, unless otherwise specified. What is unless otherwise specified? Right here. This is the situation that we have done the unless otherwise specified. This is the unless otherwise specified. Do you guys follow me? Do you follow me? Now, so that sign we refer to is which one? Is this one. This is the sign we refer to. I'm sorry. Okay, I'll come back to it. Okay, I just want to bring that to you so you can take a closer look at this guy. which sign is this referred to? Because sometimes some of our students, they thought they understood, right? Oh, I understand the restricted sign. I understand the sign which with you know, the one-to-one version of the sign. And then they come to tell me, they come back to tell the professor, oh, this is undefined. No, this is perfectly defined. Because whenever sign is mentioned, we always refer to this sign. Domain is all real numbers. 3 pi over 4 is one of the numbers in all real numbers. It's perfectly defined. It's perfectly defined. Okay? And it is not otherwise specified, right? This is the situation that's otherwise specified. Do you guys follow me? This is the situation is otherwise specified. Do you guys follow me? All right, I hope I have made that very clear. And I'm already a little bit exhausted, you know, yelling this out. Okay, so then what do we do? This only means, what does this mean? It just means the perks, you know, the shortcut doesn't apply. It doesn't apply. It doesn't apply to either case because it's outside. Okay, it is not because sign as 3 pi over 4 is not defined. It's perfectly defined. In fact, if I draw the flow, you're going to see it's actually very neatly designed. Okay, we have 3 pi over 4. That's the input for sine, right? That's the input for sine, right? The output is going to be ratio. And this ratio, as we know this ratio, right? This ratio, as we know of this function, which I just copied, the range of this function, sine, so let me just write it down here. We know of sine is always between +1 and -1. This is always true for any real number. Remember that one sentence statement, domain and range? One sentence domain range. So this is always true. And of course, there's no difference once 3 pi over 4 is the input. So this quantity, okay, so this quantity is guaranteed in the range of -1 and 1. And number between -1 and 1 is perfectly in the domain of ArcSine. You guys hear that? So this quantity, which is going to be between -1 and 1, is perfectly in the domain of ArcSine. Okay, so this number can be served as input for ArcSine. And in the end, we're going to get an output. And what is that output? That output is going to be an angle. What kind of angle would that be? Before you get the answer, you know that output is going to be between -pi over 2, 2 pi over 2. This is the power of the knowledge of understanding the domain and range. Before you get the answer, you already know where the answer must be. Okay, do you follow me? And you need this information in calculus class every single day. Every single day. You're expected to know it. You can't spend 10 minutes to figure out. Too slow. You're going to lose points. Do you follow me? Do you follow me? I'm confused. Are you confused about what? Where are you confused? Do we use the pi over 2 interval? What pi over 2 interval? Pi over 2 is 1 point. What do you mean the pi over 2 interval?
I'm confused why you put it doesn't apply, and then in the previous example, didn't we put it was undefined for one of them when it was outside of the domain?
Which one?
Number 9.
Number 9, 3/2 is outside the domain of ArcSine. The ArcSine domain is from -1 to +1, isn't it? The domain for ArcSine. And what we're talking about here is sine. The domain for ArcSine is from -1 to +1. The range is from -pi/2 to pi/2.
Okay, so the only interval that really matters is the -1 to 1. The pi/2 one is just if we want to use the
The only
shortcut.
matter to what? The only interval matter to what? This interval matters to the domain of ArcSine. So when you see ArcSine apply to anything, right? When you see ArcSine apply to anything, you have to check this number that the input has to be inside the domain, which is from -1 to +1. If it is outside, it's undefined. Do you understand that part?
Yeah, a little bit more.
Okay, and for this one we're working with, where are we now? Right? For this one we're working with, we first apply sine to an angle. And this sine refers to the sine with domain all real numbers, the sine we always know of, the sine at your fingertip. Okay, and that domain is all real numbers. So, and of course, 3 pi is one of the all real numbers. Therefore, sine apply to it. 3 pi/4 is in the domain of that sine. And the range is between -1 and 1, right? And because this quantity as a ratio is going to be between -1 and 1, so it falls into the domain of ArcSine. So this quantity can serve as input to ArcSine. The range of ArcSine is between -pi/2 to pi/2. So before you get the answer, you know your answer is going to be between -pi/2 to pi/2. Is that clear?
Yeah.
Any other questions? You guys must do the tables and do the graph, the points, the homework I have assigned in this week. If you don't do that, you look at the symbol, you may be confused. Okay? Or watch the lectures and follow the lectures and do it. Because we have talked about these two functions. Hold on. We talk about these two functions, right? Sine, whether you have a restraint on the domain or not a restraint on the domain, the input are angles. The input are, the angles. The output is ratio. ArcSine takes ratio as input, angle as output, but the ratio cannot be any ratio. It cannot be 3/2. It cannot be -5/3. It has to be a ratio between -1 and +1. That's what the domain and range says. And the range has to be between -pi/2 to pi/2. That's what we talk about. You can only measure from the angle counterclockwise up to pi/2, clockwise to -pi/2. You cannot go further. You cannot get to the no flight zone. Did I make myself clear? Farouz, go ahead.
Professor, in regard to question 15, inside the parentheses, sine 3 pi over 4, it is the original sine function, not the restricted one or one-to-one version, because we don't have any evidence to show that is the restricted version. It is just the original sine function, which is real, all real number is the domain.
Right. I would ask you to remove the word original, just the sign. Every sign you see is the sign with all real numbers as domain and range between -1 and 1. Unless otherwise specified. This is the situation is otherwise specified. Do you follow me? So they will tell you, they will tell you. If they don't tell you, it is the sign. We don't need the word original. It's just sign. Don't get into that, you know, because once you get into that, you're gonna have to clarify every single time.
So if for question 15, you added that restriction, then the question would be different.
Add
Question
what
number 15.
restriction?
The restriction you showed us.
Where do you add the restriction?
For example, sine 3 pi over 4, then comma, yes, comma, what is it, restricted?
No,
sine,
that will
no.
never happen. That will never happen.
Okay,
It's never going to happen in your work. Okay, this refer to the sign as we know of. All right,
with the domain all real numbers.
that's right. And the 3 pi over 4 is one of the real numbers.
Yes,
So when you
Thank you.
work it, you work from inside out. You work from inside out. Sine 3 pi over 4 is root 2 over 2. And root 2 over 2 is in the domain of ArcSine,
that's right.
right? Therefore, it's in the domain of ArcSine. Well, what would that be? You think about the no flight zone, and it's going to be equals to pi over 4. Okay, how is this related to the picture we did? Okay, so let me show you. Let me show you. Let me show you. Okay, so I'm going to take this, I'm going to borrow this picture. So hopefully this will help you. I'm going to take this guy. Let's do this, okay? So what I'm going to do is that I'm going to just take this graph, okay? I'm going to put it here. Okay, I'm going to give you a little bit, I'm going to give you some visual about this. On this visual, okay, I was telling you that this does not exist. Do you follow me? Does not exist. So what happened is, wait. What happened is, when we work with this guy, when we work this with this guy, right? You first, when you see sine 3 pi over 4, what do? Sine 3 pi over 4. You're gonna measure that orange arc length, the arc length, 3 pi over 4. Okay, this is 3 pi over 4. And what is the ratio? The ratio is the blue. Root 2 over 2. Okay, this √2/2, which is a ratio is the input for the inverse function. So you take √2/2, the blue, you take the blue and you go there. Okay, and then what are you getting? You're getting the angle. That's the process. Visually. Do you guys see that? Okay, so first take this down, then I'm going to show you the unit circle version. Okay, I'm going to show you the unit circle version. Are you ready? Did you write it down? So that's using the sign, the inside, and then apply the arc sign to the blue, and you get the arc length, which is fitting for the ArcSine's range requirement. ArcSine's range requirement. Okay, so now let's go to the unit circle. Let's go to the unit circle. How do we approach this, right? So this is one approach, just from the picture, right? From the picture. And next one, the next approach is that we're still working with the same scenario. Over here. Sine 3π/4. We work from inside out. So when we work the sine 3π/4, what do we do? It's ARD because we know the angle first. And this angle is measured counterclockwise and terminates over here. Okay, so this is A. And what's the reference angle? The reference angle is R, reference angle. D is a definition, right? So you see the blue number, therefore sine 3π/4 is 1/√2. Okay, so that's the first piece. So now from the first step, you get ArcSine of √2/2. Okay, and then you work with the ArcSine. ArcSine says, now you know the sine ratio is √2/2. Then you look at the unit circle, you look for √2/2. How many do you get? You have one over here, and you have one over there. Okay? Because ArcSine takes ratio to get you angle. So we got the D. Now we need to find the angle. Okay? But this is the ArcSine. In ArcSine, we say we cannot use second quadrant, third quadrant. This is no flight zone. So you are only left with this guy. And that angle, which is in the range of ArcSine, that's going to be π/4. Do you guys understand? So this is π/4. So all of these rules, yes, they're all of these rules. Is that helpful, Hazel?
Yeah.
Do you have more questions? Feel free to ask. Because otherwise, it's going to be your loss. So we're dealing with the rule of sine and ArcSine at the same time. They each have their domain and range, and all of their respective functions' domain and range must be honored. You guys follow me? Yes? So sine always refer to the sine as we know of. I know a lot of my peers or professors or whoever, they try to, give us some different names, but ultimately, you have to understand the whole concept, right? You have to, the more specific you say, the better it's a clearer. All right. Next, let's look at 17. Let's see if you guys can do number 17. I'm going to give Farouk some, some space to explain. Maybe my explanation is a little too boring and my sound is too monotone. So I'm going to open the breakout rooms. If you wish to work with Farouk, so go for it. And if you stay with me, okay, if you stay with me, which is fine, then we will work it. But I'm going to give you just a little bit time if you stay with me, right, to try to figure this out, to see if you understood my explanation. There are different ways of explanation. Sometimes I might be giving you too much, too many explanations. They're all consistent. They're all consistent. So where's my other functions? I can understand you might be overwhelmed with all of these notations. Remember, you sign up for 5 classes in one. Okay, you sign up for 5 classes in one. We're trying our best to make it 5 classes in one. Okay. It looks like Farouk is only one in there, so I'm gonna get him back. Okay, come back. Oh, I'm closing. Wait. Sorry, Farouk. I'm closing it, but I think he should have enough time. Otherwise, we can get after they come back, I'm gonna give them more time. All right. So on this case, right? The shortcut doesn't apply because -3π/4 is outside. Just because -3π is outside the domain of the restricted sign, it is not undefined because it is in the domain of sign. Okay. So if you use the word of original sign, that's fine, but it's a sign. Okay, it's the sign. I'm sorry, Farouk. Have you had enough time to do it?
That's okay, Professor.
Okay. So what issues have you identified? Okay, so you're not saying anything. Anyway,
Are you asking me, Professor?
right, what the issue you guys have there?
Oh, the issue, the confusion between the sine domain and the inverse of a sine, any trigonometric function, because they're periodic, they cannot have inverse unless we restrict it. Therefore, we use that concept, we create the inverse for sine, and we use now any sine with any angle, with any input. And we can use that concept and go for the arc sine of that. So it's a little bit confusing, but I tried maybe clear a little bit because based on what we learned yesterday or 2 days ago, none of the trigonometric function can have inverse because they are periodic unless we cut the domain, restrict it, make it 1-to-1. Then we can go by definition, create the inverse for them.
Right. We have covered those. You guys, you know, we will explain to you this one more time, but you need to go back to watch those lectures. Okay, you need to go back to watch those lectures. I would say you should watch those lectures 5 times. 5 times. Okay, I'm not because we don't have time to explain them all over again right now. We have set the stage. We have explained that. Okay, we have explained that. That's why it's very important that you keep up with the class. Okay, so I will do my best to still touch those points, right? So you need to understand this sign always refer to this sign, you guys. You don't need to ask that question because if it's not that sign, they will tell you. They will tell you. Right? When did they tell you? They told you here. See, they told you here. If I remove this, this will be a mistake. Do you follow me? So it has to be otherwise specified. And they didn't tell you that, therefore, it meant this sign. You follow me? When we talk about arcsine, it's implied the domain is between -1 and +1. The range is between -π/2 to π/2. Implied. Okay, so now how do we deal with this guy? Sine of -3π/4, right? Sine of -π/3/4. What you do is that on the picture, you're gonna measure that arc length, and which arc length, this is a negative angle, right? So you're gonna be measured all the way up here, the orange, and the blue, that's a -√2/2. And and the -√2/2 is the ratio, and that ratio will be used as input, and you get the angle. And you get the angle. The angle is the output. And the angle has to be in the first quadrant, or has to terminate in the first quadrant or the fourth quadrant between -π/2 to π/2. If I only say your angle has to terminate in the first quadrant or the fourth quadrant, I have leave some loopholes because there are lots of angles that could terminate in the first quadrant or fourth quadrant. So the best specification would be between -π/2 to +π/2. Meaning that there's no flight zone. Don't get there. Don't fly over there. Okay? You follow me? You know what? I think let's continue. Okay, let's continue. Do you guys have any questions? Anybody is confused? So now we do it from inside out. Algebraically, this is usually the work expected of from your professor, right? Sine of -3π/4. You can also use the unit circle. You can also use the unit circle. How do we use the unit circle? ARD. ARD. Okay. This is the place you're going to use ARD. Why ARD? From A to R to D. ARD, the A is -3 pi over 4. So we know the angle. So how do we measure the angle? We measure the angle clockwise, right? Because it's a negative angle, clockwise, and we terminate here. Right? And that's, so this is A. This is A. And what's the reference angle? The reference angle is here, pi over 4. And D is a definition. You apply definition, we get -1 over √2. So what's going to be in the parentheses after we apply ARD to this quantity? We're going to get -1 over √2. You follow me? That's applying ARD. Okay, the two software doesn't talk to each other. Okay, so I'm going to make 2 of these, right? So let me repeat that. A, the -3/4, 3 pi over 4. We measure clockwise. We are here. And that's the A. That's the A, angle measurement. And what is R? The positive acute angle between terminal and x-axis. D, applying definition, sine definition, is Y over R, Y over R. So Y is the green number, the blue number. So that's how we get a -1 over √2. And now we take the -1 over √2, -1 over √2, because ArcSine will take a ratio, produce angle, but not any ratio. Ratio has to be between -1 and +1. An angle has to be between -pi over 2 to pi over 2. Okay, so now with that in mind, I'm taking this number. Okay, I'm taking this number -1 over √2 or -√2 over 2, and I'm looking for -√2 over 2 on the unit circle. What do I get? I found there's 1 here and there's 1 there, right? But this is the ArcSine. ArcSine is 1 to 1. It doesn't allow me to do what? Doesn't allow me to do anything on the 3rd and 2nd quadrant. So this is out. Okay, so your angle can only be either in the terminate in the 1st quadrant or in the 2nd quadrant. You hit the wall, you cannot get over. You cannot go around and round. You cannot. So the range is, that's the meaning between -pi over 2 to +pi over 2. Therefore, in our case, there's only one choice. Okay, 1-to-1 function means what? Remember when we plot the point, they're 1 to 1, right? There's 1 point here, 1 point there. You don't have 1 point here, there are 2 points over there on this to correspond to it. So the answer is going to be what? -pi over 4. That's right, that's only choice. 1-to-1 means, first of all, for any function, the answer, the output has to be unique for the input from the domain. That's for any function. So for that input, the answer has to be unique. Question. Question. Common mistake. Okay. Is 7 pi over 4? Absolutely not. The question is 7 pi over 4? Seven pi over 4 is outside the range. 7 pi over 4 is outside the range. It cannot be the answer. Do you follow me? 7 pi over 4 will be, you get 0 for it. Got it? Why? Because 7 pi over 4 is outside the range. It's outside the range of ArcSine. No. Because 7 pi over 4, even though it terminates the same place. Remember, your angle in ArcSine case can only measure. You can only measure. Which way you can measure? You can only measure from here up to there, or from there down there. That's negative pi over 2 to positive pi over 2. If you do 7 pi over 4, if you do this, you invading the no-flight zone. That's a no-no. Did you guys get it? The answer has to be unique. What do you mean unique? One and only. Is that clear? Because 7 pi over 4 is what? Is outside the range of ArcSine. Is that clear? In fact, that's a very common mistake. Common mistake. Sometimes I see this work, okay? The student will give me 2 answers, negative pi over 4, and then they also give me a 7 pi over 4. If this happens, the student gets 0. Can we say that in this case that quadrant 1 reflects over X to define negative angle? I have a hard time understand that sentence. Can we say in this case the quadrant 1 reflects over X axis to define? Sure, you can do that. But it's all covered by angle measurement. It's all covered by angle measurement, right? You counterclockwise, clockwise. Right? It's all included, right? When this happens, student gets 0. Why? Some student will come to us say, hey, I have a right answer in it. Well, it's true you have a right answer to it, but you do not deserve any partial credit. Why? Because you need to understand ArcSine is 1-to-1. It is a 1-to-1 function. Even as a function, ArcSine is also a function. This function, for that input, it produces only one output. It should never have 2 outputs. That violates, number 1, violate definition of function. Number 2, violates the nature of 1 to 1. One to one, okay? And this also demonstrates no understanding of ArcSine. Okay, no understanding of ArcSine. ArcSine. Domain. Its domain and range. 3 violations, just to name a few. For that reason, the student gets 0. So don't do that. I have seen this many times. I'm sorry. Okay? Do you guys follow me? For ArcSine, to summarize, right? No matter what this baloney is, okay, let me just call that baloney. Your output has to be 1 and only. That's number 1. Number 2, your output has to be between negative pi over 2 to pi over 2. Period. No argument. Who said the rule? Not me. I'm not old enough to set that rule. I'm not old enough to set that rule. Relatively speaking, I'm pretty young. These rules were set hundreds of years ago. Do you guys follow me? Seven pi over 4 terminates at the same place, but it cannot be the answer because the range itself has determined it has to be between negative pi over 2 to pi over 2. This is what I have explained all along. Okay, for the range of ArcSine, you can only measure either counterclockwise and only up here. Okay, no more, no further. Don't go further. That's no flight zone. Okay, it's full of landmines. Okay, or you can only measure up here, clockwise. Okay, no turn around and round. You cannot go, if you do 7 pi over 4, you're gonna fly over the no flight zone. Does that make sense, you guys? Isn't that ARD important? Yeah? Any other questions? I will stay a little bit longer for you. No flight zone, meaning you don't fly over, you don't cross, never cross. 7 pi over 4, you get to cross it. No, no, no. Got it? More questions? Hazel? Are you there? Got it? Bring your question, please. Let me tell you, this part is very, very difficult. It's very, very difficult, okay? I'm glad you have these questions. I'm very glad you have these questions. That's why I spent all this time to prepare for this moment. I anticipated this moment, right? I've taught so many years. What do we have done earlier, those past lectures, to prepare you for this moment, this very moment. Okay, what we did to plot the points, to let you see the one-to-one, and so on and so forth. So you will not make a mistake of this sort. Okay, you will not make a mistake of that sort. terrible. This is I would say this is horrifying mistake. If you give one answer, that would be better. Even if you give 7 pi over 4, right? I would say, well, it doesn't, at least in that case, it doesn't violate the function definition, right? At most, you don't know the domain and range, and you give 2 answers. That's the worst. That's the worst. Remember, we've been emphasizing the definition of function. For any input, there's exactly one output. You cannot have more than one. You cannot have more than one. You cannot have one less than one. You must have exactly one. Now what you have 2. Do you know how bad that is? That's why there's no partial credit. None. Remember, this semester, the theme of this semester is what? Is a function. So at the end of the class, I want you guys to read the definition of function one more time. One more time. Right? One more time. One more time. Can you do that for me? Read the definition of function for yourself.
Professor, I had a question regarding the quizzes.
Yes.
I know you said that for the next 2 quizzes, one of them was going to be review over exponential and logarithm, but what did you say the second one was going to be about?
It's going to be about what are we doing now?
Oh, so like the stuff that we did in class today?
Yes. About
Okay.
ArcSine though.
Okay.
And what we did yesterday.
Okay, thank you.
Professor, same thing from me. Fears I will be in Math Study Center for the class in case if they watch the video and need more explanation. Today they can stop by 3 to 6 p.m. Math Study Center.
Thank you, Farouz. Okay.
Yeah, you're welcome. Ma'am.
So let's read the definition of function one more time. One more time. I'm going to put it to the top. Definition of function. What's the definition of function? I'm going to type it for you, okay? Don't go away. If you have to, that's fine. Okay? What's the definition of function?
A function is a rule that assigns to each element x in a set of exactly one element called f of x in a set of b.
Wonderful. So when you read it this time, when you read it this time, do you think you have more understanding to it? Now I changed the wording a little bit. Domain, exactly one element called f of x in the range of f. When you read it this time, a function is a rule that assigns to each element x in the domain of f exactly one element called f of x. Right? That initial setup I have given you guys. That definition. So now you think about this definition. The output has to be one and only. This is before we talk about one-to-one. If you violate that fundamental concept, how many points do you think you get? 0. This is why I make a function the theme of this function, this semester, because it works every moment of it. Have this been emphasized enough? Well, at least I'm trying to emphasize this, because at the door of your calculus classes, you are expected to know function very, very well. If you don't, you're not just going, you're going to have a very, very hard time. Okay. I'm not trying to make you feel uneasy. I try to make you work harder. Okay, I am. I know you already work very hard. You're doing 5 classes in one. Okay, you cannot say, oh, I'm gonna, just take a break or something. You can take some break. I'm not against it. But you have to watch each one of the lectures, I would say 5 times. 5 times. It's not because my lectures is so fabulous. No, I'm not so, I'm not that proud. But the contents I have addressed, I'm confident those contents I have addressed are right to the point that you need to understand. Okay, in the past, when we were not teaching online, we actually don't have the opportunity to record. Now with the recording, I think it gives you, we have disadvantage, we don't teach in person, but we had an advantage is that we have the recording. We have the recording. I also expect you guys maybe watching the recordings even when you are in the calculus class. Okay. That's why I made them available to YouTube. So that way you can watch it after the course is closed in Canvas. But anyway, without further ado, today is the last day this week, but please feel free to reach out to me for any questions. I mean, any questions, anytime. But you guys must, spend time, working hard on this, okay? But once you get it, you'll be liberated, okay? You'll be liberated. I'll see you guys on Monday.
Thank you, Professor. Have a nice weekend.
You too.
Thanks.
Thank you.
Thanks for the lecture, Professor.
Of course.